Let's have one more example of completing the square, but you'll notice in this case I've not got y equals, I've got 0 equals. So this is an equation which I hope to solve. You'll notice this one doesn't factorise. Factors of 20, 5 and 4, 2 and 10, 20 and 1 will never add up to minus 10. So we're going to complete the square and try and solve it this way. Half the coefficient of the x term, the minus 5 squared, okay, we've completed the square. Now if we want to solve this, we don't need to put it in the calculator. We could have done at this stage, but if we've got it in this form, it's much easier to solve from this form. Add the 5. Now we need to square root, so just like when we solve anything, we're doing inverse operations, one at a time, step by step. Always remember, when you square root something, it could have been positive or negative. We don't know, so we have to provide both options. Or we know that x minus 5 squared was 5. X minus 5 could be plus or minus the square root of 5. And now we add the 5 over to the other side. So we know that x is either equal to 5 plus root 5 or 5 minus root 5. You see, by looking at this, it's nice, easy algebra, simple numbers to work with, and it's probably quicker than writing it into the calculator. Let's do one more example of this. Completing the square again, x plus 4 minus 4 squared add the 18, square root, always remember your plus minus, minus the 4. One thing to notice with this one, root 18 can be simplified. 18 has a factor which is a square number. So if we pull that factor outside of our square root of 9 is 3, so we can pull the 3 out of there and we'll be left with the factor of 2. We've got our values of x for an equation which would not factorise nicely.